This is Mr. Allenson, and we're going to do problem number 2 from the 2004 BC test. We have two functions, f of x and g of x, and the first thing it says to do is to find the area of the shaded region enclosed by the graphs of f and g. Ends up being the space in between these two, this whole area. So to find that, we want to take the integral from 0 to 1 of the function on top minus the function on the bottom. It's pretty much as simple as that. These functions do have equations with them. F of x is 2x 1 minus x, and g of x is 3 times x minus 1 times root x. Okay, so when you plug this into your calculator with these functions for f and g, you should get 1.133. The second part, B, says to find the volume of the solid when you take this region and you rotate it around the line y equals 2. So this is kind of hard to see actually. I think it's pretty tough, but it's 2 to this line here, so it would be 2 up here, so this is kind of be the middle, and you'd have this part underneath would be the same as this part here, and you'd have this spot that kind of, I can't even show all of it because of the paper, but look like that. And so what would happen is you'd have these sections that are washers because the radius would be from here to there for the big part. And then there would be a small circle missing from the middle with a small radius from here to here. So the large radius is equal to 2 minus the g of x function, and the small radius is 2 minus the f of x function. So what you're going to want to do is go pi times the integral from 0 to 1 of the large radius squared minus the small radius squared. And when you plug that into your calculator, you get 16.179. The last thing C asks you to do is they give you this other function h. They say h of x is equal to kx times 1 minus x. Okay, so it's some other one. It's not shown here, but that's the other function. Okay, that would be the one. So it says that it's the base of a solid between h and g, this bottom one, and the cross sections are perpendicular to the x-axis. Okay, so what you want to do is you want to take the integral from 0 to 1 of h of x minus g of x, and you're going to square that because the side of a square squared gives you the area of each square, and then we integrate to find the volume from 0 to 1. Plugging that into your calculator would be what you do to get the problem, but we don't actually know k. What the problem says is write but do not solve an equation involving an integral expression that could be used to find the value of k. So the integral expression would be the integral from 0 to 1. You have to actually write this out now. H of x is kx times 1 minus x minus g of x, which is 3 times x minus 1 root x, all that squared, dx is equal to the volume, and they tell you the volume of it is equal to 15. So you can put 15 right there. Now for this problem, 9 points. On the top problem, what you've got for A is 1 point for the integral and 1 point for the answer. For B, 1 point for the limits, 1 point for what you're taking the integral of. If it's not in this form, then you're having a problem. If you got some of these wrong, then you're getting -1. But if you have it in this form, big R squared minus little r squared, you're going to get 1 point, and 1 for the answer. For C, you've got 2 points for the integrand here, but actually down here, and 1 point for the answer, for the whole thing being set up. So if you get this part right, you're going to get 1 point for that.